Ladies and gentlemen, thank you for standing by and welcome to the Pavement Preservation's 2021 webinar series conference. At this time, all participants are in listen-only mode. Later, we will conduct a questions and answers session. Instructions will be given at that time. If you should require assistance during the call, please press star and then 0. This conference is being recorded. I'd now like to turn the call over to Jason Dietz. Please go ahead, sir.
Yes, thank you, Catherine. Welcome, everybody, and I apologize for the inconvenience. We had a little bit of difficulty, folks in our web conferencing. They had a different time of start, and, well, unfortunately, we were able to get it going, and I appreciate everybody sticking with us. With that said, I'd like to welcome everybody, and thank you for joining us today. My name is Jason Dietz, and I'm with the Federal Highway Resource Center, and we're partnering with the Pavement Preservation and Recycling Alliance on a series of these pavement preservation webinars focusing on pavement preservation, extending our lives of our pavements. Today's webinar will focus on the emergency asphalt emulsion technologies. You will see a number of polls up on your screen. We ask you to take a moment to answer those, and we will close them in just a few minutes. We also encourage questions during the webinar and ask you to please take the time to respond to the evaluations at the end of the webinar. All attendees are on mute, but you can submit any questions to the chat function on your screen, and we will answer those as time permits. We will be offering PDHs for today's webinar upon request, so please let us know after the webinar if you would like to receive those. I'd now like to introduce today's speaker, my good old friend, Stefan Charmot. Stefan has been involved with the pavement materials and engineering activities for more than 25 years, mainly in North America and in Asia. He currently leads the Asphalt Technology Group for Ingevity in China and is involved with the implementation of cost-effectiveness and sustainable pavement maintenance and rehabilitation technologies. Stefan, on behalf of PPRA and Federal Highway, I want to thank you for your time today, and now we'd like to go ahead and pass it over to you.
Thank you very much, Jason. Really appreciate it. And again, hello to everybody. We apologize for the little delay we got. I would like to thank PPRA and FHWA for the opportunity to participate in the webinar today. I also would like to thank some of my Ingevity colleagues and others who helped me prepare this presentation and allowed me some time to use some of their own information and also the feedback I received from them. So today I will really try to emphasize the technical side and therefore will keep it as generic as possible, avoiding to mention brands or company names. So of course, if there is more details that we need to cover, we'll make sure to do that at the end of the presentation. So the topic today is emerging asphalt emulsion technology. So really quickly, what do we mean by emerging? So to kind of align on the definition a little bit, we would like to take emerging as upward trends. What are some of the trends that we see in the industry? And it can, of course, be something new, but sometimes it's something that used to be happening before, but has been revived or has been improved. So that will be kind of the logic behind some of the topics that will be covered today. I will get started. So far on my screen, I think that the presentation is being loaded, so I'm not sure, Jason, if it's showing on everybody's screen.
Stefan, I have it on outline right now.
Oh, okay. Well, I guess my internet is not so good, so I will just let you advance the slides then. So since we are on the outline, you can see the areas that we will be discussing. So we're going to start with an overview on emulsion, since the topic is emerging asphalt emulsion technologies, and most of the applications we'll be talking about will be involving emulsions. So we'll be talking about penetrating prime coat and dust control emulsions. We will then switch to some chip seals and some emerging applications. We'll really talk about the Cape Seal and how they can be used on high traffic roadways. I'd love to talk to you about sealants, as some of the new developments have happened in this area. One of the techniques that has some history but has also been improved in recent years is microsurfacing. So I would like to talk about high-performance microsurfacing. I would like to also discuss some information related to the benefit of combining some preservation treatment sometime. And then, of course, one area of real interest and value related to emulsion application is for structural enhancements of pavement. So we'll talk about emulsion, FDR, and cold in place recycling, and cold central plant recycling. Okay, then I'll let you move to the next slide. So I think we start with a poll question, and as people answer that, it was very interesting to see at the beginning of the webinar that we have a very well-balanced attendee list as far as road owners, academia, suppliers, testing lab, and so on. So we have a really nice, diverse panel of attendees today. So look forward to the Q&A at the end and the input from all the attendees. So regarding the poll questions, should I give it a few more minutes, or we?
Stefan, are you able to see the responses?
Yeah, I see that. Yeah. So
okay.
What I see on my screen is that most of the answers are on the chip seal, and actually, I believe that actually the largest usage of emulsion volume-wise is actually on tack coat. When we look at the consumption of emulsion around the world, I believe it's used for tack coat. And where I'm coming from with this information is actually from the IBEF, the International Bitumen Emulsion Federation. They kind of conduct surveys, so you will see at the end of the presentation their helpful links. So their website has some valuable information, and one of which is regarding emulsion usage. So that was a little bit of a tricky question. So not that it's so critical, but you know, definitely using emulsion for tack coat is very important application, because that will really play a big role in the structural enhancement of the pavement by bonding the layers well together. With that being said, emulsions can be used for a very large range of other applications, and that's what we will try to emphasize in the webinar today, some of the other value-added applications of emulsion. So we can move to the next slide, Jason, with asphalt emulsion. Title slide, where we will again talk about overview, some classification, application, and would like to say a few words on production. So next slide is what is an asphalt emulsion? So an asphalt emulsion can be defined as a homogeneous mixture of two insoluble substances, and this is made possible by the action or the usage of a surfactant. As illustrated in the picture on the slide, a surfactant is a chemical that has an oil-loving tail and a water-loving head that can either have a positive, negative, or no charge, depending on the type of surfactant that is used. But basically, this layer that gets placed on the outside of the asphalt droplets will play a very big role in keeping the system somewhat stable and allowed to make an asphalt emulsion. We can see also in the lower right corner the picture of an asphalt emulsion through a microscope, where you can see the an actual asphalt emulsion that has been diluted. So you can have the light going through, and you can see the spherical particles of asphalt suspended in water. Just as a fun fact, a typical average size for these asphalt particles is in the range of 3 to 10 microns, so with an average size probably around 4 or 5 microns. So this is 10 times smaller than the a human hair size. So these are very small droplets that we're able to produce. And at some point through the life of the emulsion, it's intended to break and basically go back to more of the original asphalt stage. And we'll talk more about that in the next few slides in application. Next slide, Jason, please. I think the title should be Emulsion Classifications and Application. So the emulsion can be designed specifically for the application that it is intended for. And one way to classify it is by being either a slow set, quick set, medium set, or rapid set. And that will really play a big role in how these emulsions can be used. Typically for mixing purposes, if you have to mix it with some aggregates or some material, you need to use a slow set or quick set type of emulsion. In the case of a spray applied application, like in the case of a chip seal or a tack coat or a fog seal, you want to use more of a rapid or medium set type of emulsion. So the difference between these different setting classifications is really how quickly the emulsion will break and how quickly it can be destabilized depending on the environment that it is exposed to. So next slide, please. That is about emulsion production. So I'd like to mention a PPRA website link that you can access from the slide. And basically, it really goes over some basic information regarding formulation, the use of an important a device at a manufacturing site, which is a colloid mill. This is what is used to really produce the emulsion. The main components that the mill will need to produce the emulsion are the asphalt as one of the main components, and to be sheared in these asphalt droplets. And also another important component is often referred to as a soap solution, which is a mixture of surfactant and water and caustic or acid as needed, depending on the type of emulsion that is to be produced. The asphalt is usually heated at around 295 degrees Fahrenheit or 145 degrees C, and the soap solution, again, the mixture of the surfactant and the water is typically around 50 degrees C or 122 degrees Fahrenheit. So that the temperature is favorable for the asphalt to be sheared and be turned into these asphalt droplets. And of course, you have to select your temperature depending on the type of asphalt you're working with. But in any case, you are always looking for a discharge temperature out of the mill below boiling temperature. So you can't have a boiling emulsion coming out of the mill, otherwise it will destabilize the emulsion. Some other considerations that are outlined by this PPRA link is not only after making the emulsion, some considerations need to be given to how the emulsion will be stored, typically in a vertical tank, and then also how it will be transported, how soon it will be used, and so on. And of course, from the beginning, what did you formulate this emulsion for, and basically the intended purpose as far as once you either mix it or spray it, how quickly you want it to break and cure. So next slide, please. That will be talking about asphalt emulsion, learning and certificates. So for people who want to learn more about emulsion, I really would like to mention some of the programs that are available and actual self-learning and certificates that one can obtain. It is a program that is managed by Professor Andrew Braham from the University of Arkansas, with the involvement of industry experts and other knowledgeable people. And they currently have 4 modules that you can get more information on. One of the module, if we can call it module number 1, is Introduction to Asphalt Emulsions. You also have another module on the manufacturing of asphalt emulsion, another one on application of asphalt emulsion, and then the 4th one on achieving quality of asphalt emulsion. So this is a very well done curriculum, and you can basically get certified from going through this information online. So I highly recommend to take a look and possibly sign up for some of these certificates. You have the link, and I think an easy Google browser search would be Asphalt Emulsion UARK for University of Arkansas. So that will really kind of conclude the background information. I apologize, it's a little short, but really would like to spend time on some applications. And the first one that we have on our outline today is penetrating prime coat, dust control, and tack coat on mill surface, because these are opportunities that we really face into the real world as far as providing a product that will perform up to expectations. So next slide, Jason. I think it should have the title Prime Coat, Dust Control, Mill Surface Tack Coat with a few pictures. So one of the key objectives for this type of emulsion is to really penetrate in the substrate that it is being applied on top of. So we still have, at least in the U.S., we still have quite a few unpaved roadways, and I believe, if I'm not mistaken, the percentage is around 32% of the total roads out there. So for some of these roads, definitely there would be some benefit in applying some emulsion, either as a penetrating tack coat, if it is intended to receive something else such as a thin overlay on top of it, or just as a dust control. Another application is really over a mill surface. One of the techniques that is often used is mill and fill. So the first step obviously is to mill the existing old asphalt concrete. And this milling process actually creates dust that is very difficult to remove. Even using a broom, it's not so easy to get rid of all this dust. And this dust will act as a bond breaker, and your tack coat will not really bond well to the milled surface. So one way around that has been to either use cutbacks or emulsion containing solvents. So these solvents, such as kerosene, can help penetrate more and go through some dust. However, these solvents are not so environmentally friendly, and they can actually create some pollution. The reaction of the vapors with the sunlight can create some smog. So from a sustainability standpoint, there's definitely great value in trying to minimize the use of solvent. So let's go to the next slide, Jason, please. So one way to kind of look at it is to try to do some experimental work in the lab and taking a representative sample of the material to be sprayed on and kind of evaluate that in the lab. So as you can see on the slide, you have a mold with the fine sand or the material that is available from the project, and we're going to try some different products to see how well they will penetrate and how the behavior will be on the surface of the sprayed substrate. So we can immediately see what happens when you apply the emulsion or the cutback onto the surface, see how well it penetrates, and we can define a fixed time to evaluate the actual penetration depth. In this setup, the mold and the sample is prepared in such a way that we can open the mold and kind of cut the sample in half easily and see the penetration depth. So what we can see if we compare a typical cutback, which is basically only an asphalt mixed with a solvent, we can see that very often this type of product creates a sticky surface, which is not favorable because it will create some challenges for what you want to do next, or even have traffic going over the surface and picking up the applied material. Some traditional emulsions, such as a classical CSS, can do an okay job as penetration, but we're trying to see if there is a way through upgraded chemistry and an improved system or a new technology that would allow to have a better penetration and also have a less tacky surface. And through formulation and innovative chemistry, this is something we can achieve. So we can go to the next slide, which now shows a little bit of a patchwork out there on an existing aggregate base. So of course the lab is one part, but we can further confirm the quality of our penetrating prime by even trying different formulations or different things and seeing how it really behaves in the field. Again, the goal is to achieve maximum penetration, probably try to not have a tacky surface. So if you have to place an asphalt concrete overlay and the equipment kind of going over the applied tack coat will not easily pick up the material that has been sprayed on the aggregate base. So this is a little bit of experimental work and preparation work to confirm the formulation. And then if we go to the next slide, which is really now we're talking about a real project. So we have kind of narrowed down what is our best formulation, and we're ready to use it on the project. And of course, again, we had in mind to come up with an emulsion formulation that would be ideally solventless, so that would be sustainable and better to some degree for some of the properties that we're looking for. And we can do a full-scale project, and in this case, we can see the original aggregate base on the left side of the picture. And for this project, that was actually a cement-treated base, and cement-treated bases are very challenging as far as the penetration because they're very tight surface and they contain cement in the aggregate structure, which makes it somewhat challenging for penetration. So the improved formulation that was used was a typical 35% residue, so that it can really be applied in a quantity large enough that gives very good coverage. And then after the spraying is done, we can observe the curing, and more importantly, we can also measure the penetration. And ideally, we'd like to see probably some penetration depths on these aggregate surfaces to be in excess of 5 millimeters or 0.2 inches. So I'll move on to the next poll question. And as you can see on the screen, important penetrating prime emulsion characteristics include solvent content, residue content, penetration depth, ability, or all of the above. I think everybody answered that very well. The answer was D. So great job on that. Now let's switch topics to chip seal. So again, chip seal is not a new technology, but there's definitely some formulation enhancement that we can do to expand the usage of such valuable pavement preservation technique. You can see on the next slide common chip seal types. So a very common one is really what is referred to as a single chip seal. So basically you have the spraying of the emulsion followed very soon by single chips. So you have the double chip seal version. Often the smaller aggregate size is used, a smaller aggregate size is used on the surface to make the right quality better and also the noise level a little lower. Now, by going 2 layers of chip seal, as you know, you can definitely address roadways that are a little more distressed. So because you're going to have some extra addition of the emulsion layer that will have a lot of benefits in terms of reflective cracking or sealing of the existing roadway if you have more cracks. Another application related to chip seal is a cape seal, which is basically a single chip seal, usually followed by slurry seal or microsurfacing. And you have different variations where you can use also fiber or geotextile reinforcement on top of the existing surface if you have very severely cracked pavement to help maximize the or delay the reflective cracking. So let's go to the next slide where the title is Challenging Conditions, and I would like to give you an example. Usually a suitable time to do a chip seal is when it's very warm and basically summertime. So usually warm weather is really your friend when you do a chip seal work, because that will really help the chips to really embed into the emulsion. And that way you will not lose chips under traffic. However, conditions are not always ideal, and you sometimes have to do a project, either early season work or late season work, or it was supposed to be good weather, but all of a sudden, you know, it's really bad weather, and you have cool temperatures, high humidity, or you have a lot of rain that makes your existing roadway damp. So I'd like to give an example here where a project was done, and in this case that was using a double chip seal because the existing roadway condition wasn't so great, so a double chip seal was more suitable. And this project was really in the late fall, so again, not very suitable condition. You can see on the picture on the left side, you actually have the existing surface very wet. This is really not recommended, but if your conditions are like that, you know how to really deal with the situation if you know for the rest of the year it's only going to get worse. So what one way around that is to really formulate for the conditions, and in this case, typically one approach is to use an emulsifier system and a type of rapid set emulsion that is what could be called ultra-fast chip seal. So basically your emulsion will be breaking very quickly. So you won't rely on warm weather to have some emulsion break help. So you can see the job was done with these conditions. The emulsion was applied and then followed by the chips. So if we go to the next picture, we can see how this project turned out. Again, on the left side, you know, under these very challenging conditions, first of all, you had a roadway with a relatively poor condition, and then as far as cracks and so on, and the time of the year was not so suitable. But looking at really the project 2 months later, even with some snow and really further cold weather, the overall outcome turned out fairly positive. And that was really made possible by customizing the emulsion for the condition of the project. Again, this is not really recommended, but sometimes the conditions are such that measures have to be taken to deal with the situation. So the next topic on the next slide will be chip seals on high traffic roadways. Traditionally, chip seals are used on really low volume roads or relatively low volume roads, and one of the main reasons being that under the more heavy traffic you have a chip loss, and these flying chips can turn into broken windshields. So in the case of a higher volume roadway, the system needs to be engineered again for the heavy traffic conditions, also relying on a fast braking system. So you want to be able to grab these chips and kind of brake and hold them right away. Of course, the aggregate selection and some of the aggregate properties will also play a role in the outcome. Typically, if you don't want to have flying aggregate under the action of the traffic, you want to apply a lower application of aggregates. And furthermore, in the design phase, some lab work can be done to evaluate chip retention and make sure that the system is compatible and suitable for the condition that it will be used for. Then, of course, after the lab and the formulation is defined, a prudent approach is to do a test strip and basically build a short section out there on the project and making sure that everything is okay. So I'd like to give you an example on the next slide, where basically some chip seal work can be done on the expressway. So another thing that you can do on the expressway, if you know you're going to have some fairly heavy traffic, is to use a smaller aggregate size. So definitely a smaller aggregate size. In this case, that was a 3 to 5 millimeter chip, or number 6, number 5 sieve size. So that will have less of a tendency to fly around and do major damage if you have a few loose aggregates. Again, not over applying the aggregate is recommended, and to further enhance the aggregate retention, a FOX seal can be applied after the chip sealing. So we have cases where that can be done on heavy traffic roadways such as an expressway, which would be an interstate in the US. So I'd like to go to another application that is related to Cape Seal. And for that, really, as we discussed earlier, a Cape Seal is the combination of a chip seal and microsurfacing. And then this is also a very useful technique that can be used when you have a more distressed pavement, where the chip seal, through the relatively thick application of the asphalt and emulsion membrane, will really seal many of these cracks and help delay or prevent some of the reflective cracking, seal the existing surface very well. But if your finished surface requires something other than the chip seal, which is usually a fairly aggressive texture, so for urban setting, it may not be appropriate. So the application of a microsurfacing on top of that would be highly beneficial. And not only for urban setting, but the case that we will be discussing in the next slide is also the possibility to apply a Cape Seal on a high volume roadway. So next slide, please. As we can see, again, we can do, when well prepared, this type of work even on an interstate or an expressway or a roadway with relatively heavy traffic. If we know we're going to use the microsurfacing on top of the chip seal, we can go with a larger aggregate, because as long as we cover it with the microsurfacing, then we won't worry too much about larger aggregates getting loose and possibly doing some windshield damage. So after applying the chip seals, shortly after, we can do the microsurfacing application. So next slide, please. So hopefully to keep everybody on top of the discussion here, would like to ask a question related to chip seal. So please, if you could read it and share your answer.
Hey, Stefan, while folks are answering that, we had a chat question about high volume roadways using a polymerized modified emulsion. Does one always have to use a polymer modified emulsion, and why would a polymer modified emulsion be a better product to use?
Yeah, I think that's a very good question. I'm sorry, Jason, for missing that. I wasn't paying attention to the screen here. So yes, usually a polymer modified emulsion would be very helpful because it will allow for even a better chip retention, kind of improving the adhesion to the bind to the rock, and also improving the cohesion of the asphalt residue as well. So it will help you against some bleeding. So if you have some really heavy traffic going over the chip seal, the one thing that the polymer will do will be to increase your softening point and basically allow to resist bleeding better. So I think two main purpose there, or benefit from using a modified emulsion, the bleeding resistance as well as better chip retention.
One other question, Stefan, is there a recommended time between the application of the chip?
Yeah, so usually this is really, the time it takes to have enough chip retention. So one test that's easily done is usually people use a broom after applying the chips and kind of rolling it, letting the emulsion really break and getting some curing. So if when applying the broom on top of the chip seal, if everything stays there and basically we don't have any loss, that's already a good sign. So ideally, the more time you give it, the better. And the way to do that, if you don't have very stringent return to traffic requirements, you can use also a pilot car to kind of have slow moving traffic on top of the chip seal, so that can buy some time and allow for more strength buildup and better chip retention. So, usually depending on the system, and that's where the emulsion formulation will play a very big role. If you use one of these ultra-fast chip seal emulsion formulation, you could open to traffic relatively quickly within a few hours, definitely, and just have that turned back to traffic relatively quickly. So the answer to the poll question was D. So the traditional chip seal, and definitely, being a low risk, and it's a very suitable application for low volume roads. Now, if you have other conditions, either cool weather, early, late season work, or want to use it on a high volume road, through formulation and engineering the system, that can also be done. But definitely some careful attention needs to be used to make it successful. Okay, so let's switch to sealants. That's a very interesting also application. So we'll talk about POC seals and a kind of newer type of sealant that also falls under what people have defined as mastic seals. So let's go to the next slide, please. So a sealant basically is what you can do to seal your existing surface. So one of the technique that is an option is to use a POC seal. So that definitely will seal the existing roadway, and a POC seal, as defined on the slide, is a light application of a diluted emulsion without aggregate. And this type of POC seal can be either with or without a recycling agent. So depending what the goal is, if it's really to try to restore some of the properties from the aged oxidized asphalt, then a rejuvenating agent can be used into the formulation, or in some cases it's just a non-rejuvenating or recycling agent containing emulsion. One of the challenge when applying just a POC seal is the friction. So that can definitely be a concern. So in some cases, a light aggregate, a light application of aggregate fines is done to try to address or mitigate the loss of friction that could be happening from just applying the binder itself. Now we can see from some studies and over time that you know, a FOX seal can do something to the road, and if you compare a no FOX seal versus a FOX seal section of a roadway after a few years, you can in some cases really see that the FOX seal was beneficial. So next slide, please. Another type of sealant that's becoming more popular and that has been further engineered and developed in recent years falls under the category of what people call Mastic Shields. And this is a mixture of an asphalt emulsion with fine aggregates, again, to try to address the friction concern of the FOX seal using polymer and also some other additives as needed. So the binder emulsion itself is formulated in such a way that you get quick cure time. So basically you want your surface to be able to dry relatively quickly after application. So this type of materials are very interesting. They have a kind of thixotropic behavior, so they kind of have some body, some viscosity when they are in the resting stage, but as you start mixing them, shearing them, the viscosity gets lower. As soon as they're applied, then the viscosity goes higher, and eventually they cure and do the job they're intended for. So what's interesting with these products is that they're kind of combined together from the beginning. So they really offer some value in terms of quality assurance, because it's easy for a road agency to take the sample and everything is everything is there. So it's not that, you know, sometimes for a chip seal you have to really sample things separately and so on. It's not so easy to get the whole thing and do some quality assurance. So you can see on the slide, you know, this what the surface would look like before and after an application. It's still a relatively thin treatment, but can definitely be useful in case of a highly oxidized or a pavement that starts to really suffer from rattling. So next slide, please. So again, what's interesting with this type of materials is the process. They usually require a specialty truck sprayer system where there is a mixing inside the truck so that the fine sand is kept in suspension inside the system. Because over time, by gravity, it would have a tendency to fall down to the bottom of the tank. Even though there is some viscosity to the product, the agitation allows for the fine aggregate to be well dispersed into the system. And this is typically applied to the surface, so it can be done relatively quickly and again with the goal of having a quick dry time and a quick return to traffic. So usually it's aesthetically very pleasing. So another poll question to get some feedback from the attendees. Yeah, that was a very easy one. So again, you know, some benefit there as far as quality assurance. Let's move on to the next slide. So we'd like to say a few words about high performance microsurfacing, because this is also a very useful pavement preservation technique. So let's go to the next slide, starting with really a definition. I think many of the attendees are familiar with microsurfacing, but very quickly a review of what microsurfacing is: combination of aggregate typically a polymer modified emulsion, some filler, either cement or lime, and then it's applied at about 3/8 of an inch. So it's a very very cost-effective technique, and one of the benefits, in addition to speed of application, is that it can be usually traffic ready in about an hour. It can also be done at night. One of really the key benefits of microsurfacing is that it can really restore friction. Of course, it can seal the pavements, fill some of the cracks, extend the life of the roadway, but really a key benefit is to restore friction. If you have a roadway with poor friction, microsurfacing is definitely a good option to restore the friction. There are specifications related to how to do microsurfacing that are mentioned at the bottom of the slide. We can go to the next one. One goal, like many of the treatments that we do, is to turn them into a high-performance treatment. So there is no exception. Microsurfacing is also an application that we want to try to get the most out of, and basically trying to further extend the life of the treatment. So if you take a basic slurry seal, let's say, depending on the roadway condition, maybe it would last about 3 years. If you do microsurfacing, traditional microsurfacing compared to slurry seal, because of the polymer in the system and so on, some higher requirements, maybe you get 5 years. And really our goal, what can we do to try to get even 8+ years? So really, when we extend the life of a treatment, from a life cycle cost analysis standpoint, it becomes very valuable to an agency because you basically get a better return on your investment. Let's go to the next slide. So what are some of the key variables that will take you in the direction of a high performance microsurfacing? Of course, the aggregate quality is very important because it's still a big component of the system. So if we can find good quality aggregate in terms of finding the right gradation, maybe non-reactive aggregates that are very compatible with the emulsion, that's very suitable. Of course, the asphalt itself can play a big role in the performance of the system, and there are some characteristics in terms of the saturates, aromatics, rosins, asphaltene profile that can be more favorable. But sometimes, the asphalt is kind of what you have, and you have to try to make it work. The emulsion itself, the formulation, of course, will play a role, and the emulsion properties, such as particle size, residue properties, will also play a big role in the performance of your system. Specification is really also key. What are your requirements for these materials? What are your requirements on the job mix formula and the mixture properties that you're trying to achieve? So now, regardless of maybe what the specification is, and if you have to deal with the materials that are available for the project, the formulator wants to probably always try to go beyond the specification and really design and formulate the system for the project conditions and the material that is available. So there is some room for the designer, for the emulsion formulation, to try to accommodate and maximize some of the properties that are important to turn the microsurfacing, in this case, to a high-performing system. Of course, the workmanship, quality control, quality assurance, and in the first place, the site selection will play a big role on the expected life of the system. So let's go to the next slide. Since we talked about specification, really want to recommend to go to the ISSA website. There is a lot of information on microsurfacing and other preservation treatments, one of which that is kind of going to be available very soon is an updated design and inspection manual. So that's a very good tool to make sure that high quality projects are constructed. I also would like to mention that many agencies, some DOTs, and even ISSA, they had a revision to the specification. The technical bulletin A 143 that kind of specifies how to design microsurfacing has been revised, and I think it's last year update year. Some DOTs are also working on their specification to get feedback from their applicators, their suppliers, to see what changes can be made to the specification to improve it. And I just want to mention, in my part of the world, there has been also some work done in some specification revisions. There are a few things I'll just mention, a couple things from the proposed revision. The first one is on the gradation. If you go to the traditional gradation, the band is fairly wide. So, for example, on the passing 200, the typical range for microsurfacing is 5 to 15% passing the number 200. This range may be a little too large because, you know, if you don't have enough fines, you're not going to have a good cohesion of the mix. If you have too much fines, it's going to create some other problems as far as potential for bleeding and also workability during the placement of the system. So this revised specification has a narrower band, so instead of 5 to 15, it's now proposed to be 6 to 12%, for example, for microsurfacing type 3. So I think that's an interesting little recommendation there. Then I'd like to mention in this spec, since one of the requirements is very often quick return to traffic, many of the things that are done, we always want to try to have minimal impact to the traveling public. So having the treatment being applied quickly and being able to return to traffic quickly is very important. So how can we measure that, you know, in the design phase? So the traditional microsurfacing specification has a cohesion requirement, and there are also some other tests that some others have developed. But in this new spec, interesting, there's a new test that's being proposed that is called the initial curing abrasion loss. So I'll show you on the next slide what that looks like. So please, Jason, let's move on to the next one. So what's interesting, again, it's a new test. There are many other tests, so I'm just mentioning this one because maybe it's of interest to you to evaluate a quick return to traffic system. So it uses some already available equipment, wet track abrasion test that, you know, is part of the original mix design. So the equipment is available, and basically what is proposed with this new test is to make a thicker sample to basically cast a microsurfacing using the full gradation according to the job mix formula to all the components that are in the design, to basically make a sample about ½ inch thick, and then letting it cure at 25 C and 70% humidity for 2 hours. Of course, these curing conditions can be adjusted also based on field conditions. If you have cooler weather, you could condition them at a lower temperature. And then after 2 hours, you do this abrasion test for 5 minutes. So this is a very severe test. We kind of tested it a little bit, and you can see the picture. The second one to the right is basically a non-suitable system that fell apart relatively quickly, versus the last picture on the right is a satisfactory system that made it to the end of the test and didn't have any loss within the 5 minutes of the abrasion. So interesting little test there. You know, needs probably more work to really validate, you know, how related to performance it is as far as return to traffic and so on, but wanted to share that as something new. Let's go to the next step. Now, I think an interesting topic related to microsurfacing is what we could call line extension. So we have the traditional microsurfacing, again, going back to maybe the ISSA guidelines, what we know what that is. So some people are fairly innovative and trying different things. So one of which is to use fiber. So people have tried all kinds of different fibers, from polyester to glass fiber to rock fiber and so on, basically to try to improve the properties of the microsurfacing. And you can see the picture on the right side lower corner. It's basically a fiber cutting machine that is mounted on the micro paver that can cut and add the fiber into the pug mill just before it's being applied on the road. So that's one area, again, with the goal of trying to make the system more crack resistant. Related to the earlier question, we get some benefit from using polymers in these treatments. So some have gone to very high polymer content to improve the performance of the system. So that's an interesting line extension. Another one is to actually use different gradations. The typical conventional microsurfacing is a well-graded gradation. So some applications are looking at using more of a single size, almost like an OGFC, like using emulsion, microsurfacing emulsion. So by doing that, you can see that's the picture on the upper right side of the slide. So that allows to, depending on the size of the rock that you use, if you use a 3 to 5 millimeter single size aggregate, you could potentially place even the application a little thinner and just still have a good texture. Some other gradation changes that have been used also instead of a well-graded is to use a gap-graded gradation with the goal of really increasing the macro texture and increasing the friction and retaining macro texture and friction over time even better than the traditional system. So these systems can either use fiber or not. The original idea behind using the fiber is to better hold the a thicker film of emulsion residue asphalt when using a gap-graded gradation. And then another type of microsurfacing line extension is to use recycled material. So we can use slag, we can use wrap, and some when it comes to using wrap, we know projects that have been done with very different wrap contents, from the example that I'm sharing here on the expressway, on the interstate, 30% wrap microsurfacing, and we know some areas of the country in the US where they use 100% wrap to do microsurfacing. Another application using recycled material is to use crumb rubber. The crumb rubber can be added into the aggregate as a dry process, or can also be used with the emulsion as another option as well. So these are, I think, interesting application or line extensions. Let's go and take a little bit of a break with another poll question here, please. I think that's right. So I'm sorry, maybe the questions are too easy, so we'll try to make them a little more challenging in the near future. Great. Let's go to the next slide. So as mentioned in the outline, would like to say a few words on combination of preservation treatments. And there I really have to mention Ncat and all the good work that they've done also with their preservation, pavement preservation studies. So you can go to the website and find out many details on their studies there, and they have people mentioned here who have been very involved and are very knowledgeable in the test track activities, but also these pavement preservation studies. So let's go to the next slide. So I believe most of you are familiar with the National Center for Asphalt Technology, and they're very famous for their full-scale test track. They have, since 2012, embarked on pavement preservation studies, starting with a low-volume road, Lee Road 159, and then a few years later, 3 years later, going to a higher volume road on US 280. They also had some preservation treatments applied on the test track. Let's go to the next slide. So here is for the low volume road, some of the cells that they use, where you can see the fiber reinforced chip seal, scrub seal as one of the techniques that was evaluated, of course microsurfacing, chip seals. So I just show a few examples. They did very many different techniques that they evaluated over time, looking at reflective cracking, looking at rutting, looking at pavement condition, looking at smoothness, and so on. So it's a very, very in-depth evaluation of different preservation treatments. Let's go to the next slide, please. So again, want to thank Ncat for allowing me to use some of their information. And you can see here a table from one of their reports that shows some of the treatments that they evaluated. And I would like to focus a little bit on the combination of surface treatments. So let's go to the next slide. Again, I really encourage you to go to their website with their reports, where you have really the in-depth technical information and analysis of the performance. But I'd like to kind of use more pictures to kind of express some of the observations that can be made from combination of treatments. So starting with the low volume roads, Lee Road 159, we can see the condition of the roadway 9 years later. It's hard to believe it's already 9 years. So always very valuable to have a control section. So on the left side, you have a section that basically received no treatment. So you can see, obviously, it has a lot of cracking. It wasn't maintained, no actions were taken to extend the life of the pavement. So a single chip seal did some benefit. You can see you have much less cracking. So again, chip seal are very, very effective at sealing existing cracks and preventing some of the reflective cracking from happening. So the next picture that we can see on the right side is a single layer chip seal, and before that there was some crack sealing done. So it may not be so obvious on the picture here, but we can see from their study, from their report, that definitely the crack sealing is beneficial to, especially when it comes to reflective cracking and severity of the cracks that will reflect through. So next slide, please. So again, looking at some other treatments on Lee Road 159, scrub seal. Again, keep in mind what the untreated reference section was. You had a lot of cracking, so scrub seal was amazingly effective at taking care, extending the life of the roadway, and preventing some of these reflective cracks from happening. The fiber containing chip seal also did a really nice job at performing well over time and resisting the reflective cracking. The double chip seal and triple chip seal also show some noticeable benefit as far as overall performance compared to the control section, and really good crack resistance. All that is expected, but I guess to see it really visually is very reassuring and very telling. Let's go to the next slide, please. This one also, the Lee Road 159. So we can see a single microsurfacing on the lower side of the picture compared to a microsurfacing after doing some crack sealing. Again, the benefit of the crack sealing is evident, and that really confirms and indicates that crack sealing is a very important step in pavement preservation and should really be done when possible. Next slide, please. Now we're kind of moving to US 280. I'm sorry, I think it's US 280. So that's the higher volume roadway. Since it was done 3 years later, now the pictures we have are 6 years old. So we can see, again, the single layer microsurfacing compared to a double layer microsurfacing. And of course, we expect better performance from a double layer microsurfacing from the extra thickness, but now we can really quantify what this benefit is, and we can visually see it on these pictures. Next slide, please. So really, again, I want to thank Dr. Vargas for letting me use her picture to convey the message of the benefit that we can get from combination of treatments. Now, we see definitely that these combination of treatments will extend further extend pavement life. Now, of course, we have to look at it from a life cycle cost standpoint and also time of construction, disruptions to the traveling public, and really assess the full benefit of these combinations. But from a performance standpoint, there is definitely some value in combining treatments. Again, more details from the actual Ncat reports. Next slide, please. So thank you for making it to this point so far. We have two more applications to go through. So the first one of the more rehabilitation type of applications using emulsions is emulsion full depth reclamation. So we'll talk about the emulsion used for that, the design process, and also would like to illustrate this kind of application through a case study. So let's go to the next slide, please. So full depth reclamation, just very quickly about the process. So usually the machine that is used to do it is a reclaimer. So you have a grinding machine, very powerful, that can go fairly deep into the structure and kind of recombine, regrind, pulverize both the existing asphalt concrete and some of the aggregate base or layers that are below the asphalt concrete layers. So you pre-pulverize or you pulverize, and then at the same time you can add water, add emulsion. You could do this step in one run, or you can do it in 2 steps. If you need to reshape the roadway, you could just pre-pulverize, reshape the road, and then inject the emulsion, the stabilizing agent, or do it in one phase. Because the treatment usually is deeper, you really need some soil type of heavy compactors, also known as pad foot, and then to really get very good compaction throughout the whole thickness of the reclaimed layer. And then because these rollers will leave some marks, typically you use a blade to remove the mark, and then you do your final compaction using steel and pneumatic rollers. So that's for the process. We can go to the next slide. So I'd like to really, again, PPRA has really put some really nice webinars, and there was one actually almost exactly a year from today on engineered emulsion. So basically emulsion that are specifically formulated for this application. So it's a really nice webinar, and so I suggest you to kind of go, and if you have time to kind of listen to it. So we hear this terminology a lot using engineered emulsion. So what is really an engineered emulsion? So it's really kind of an emulsion that is designed specifically for the project or for the type of application that is being done for the job site conditions. So it's kind of working backward. It's kind of what are the final properties that you need from the mixture, from the finished compacted mixture, and establishing what your emulsion formulation and asphalt base selection needs to be to achieve these goals. Let's go to the next slide. So from a design process, selecting the asphalt, especially kind of looking at the PG grading, is a good start, is a good step there, and then formulating for performance. So making sure it's compatible with the aggregate or the material being recycled. That is usually a combination of wrap and aggregate base, and then finding out, you know, how to formulate it so that we get very good coating, good dispersion of the emulsion that will give good durability, gaining strength quickly, so the cure is also accounted for, and then of course, you know, the time of the year that the project is done. And overall, you know, like what we do in hot mix is trying to find the right balance between strength and cracking resistance, and also making sure that some important properties such as moisture resistance are addressed. So ARA has some really good guidelines on how to design emulsion full depth reclamation systems, and also recently AASHTO has developed some specification to do that as well. So let's go to the next slide, please. So as far as a case study, I would like to mention emulsion FDR that was evaluated at Main Road, and the value to bring up this case study is because it's very well documented and the performance is followed very closely. So we'll use this location and this past project for further details regarding the performance. So let's go to the next slide, please. So at Main Road, in 2008, there were different emulsion FDR sections that were constructed. So I think in Minnesota, they call it SFDR. So it's stabilized, I believe, full depth reclamation. And using emulsion, we can see some of the cells that were constructed, and the traffic is about 30,000 ADT with about 14% truck. The original structural design was for 3.5 million easels. And what's very interesting is that from these sections that were built, they really exceeded the design life of the project. And when they really look at it very closely in a few years later, in 2016, the design life was far exceeded, and we can get more details from the table on the right side with what the differences were between these cells. So the amount of wrap was different. So cell 2 had 50% wrap when doing the FDR, combining the existing asphalt concrete with existing aggregate base, versus cell 4 was pretty much 100% wrap, and therefore required less emulsion to be used as the stabilizing agent. But really the bottom line from this site and this well-documented research is that really from an overall standpoint, from a structural enhancement benefit as well as cracking resistance, really the emulsion FDR did a really nice job. So there's definitely more information that can be found from Main Road on these cells. So next slide, please. So this is the final topic that I'd like to go over with you today is enhancement in cold in place recycling and cold central plant recycling. So we'll talk about just the process again as a quick refresher, and I think some really recent interesting research that has been done regarding readiness for traffic and overlay. And then would like to also mention the concept of a balanced mix design that can also be applied to these type of mixtures. And then we'll also share with you some early overlay project example. Let's go to the next slide. So as far as the cold in-place recycling process, you can see here on the picture what a cold in-place recycling train can look like, and that's really the full train. So basically going from the right side of the screen, you have the support trucks, and then next you will have the milling machine that will take the wrap and put it into a crushing screening unit to achieve the maximum target wrap size, and then it will go into a mixing unit where the wrap will be combined with the emulsion and water and what is needed to make the final mix. Eventually put down on the existing surface in a windrow, then picked up with a pickup machine and put back into a paver and then compacted. So that's, you know, the full train that really has a sizing, crushing, screening, crushing unit as part of it. So next slide. The very short version on the opposite spectrum is what you have on the left side, upper left corner, is basically a milling machine that can also add the water and the emulsion during the milling process and feed directly into the paver. So now we're talking like really, really short or much shorter system. So the difference obviously is in not having the screening and crushing unit, but you know, some of that can be done to some extent, you know, through setting up the speed and the rotation and the pressure that you apply during the milling. So, but basically there are different equipment that can be used depending on where the job is at and what the goal is as far as you know, controlling the wrap relation. I'll start with the pictures for the cold central plant recycling in the lower part of the slide. So when you do, if you don't do cold in place recycling and you have wrap milling, so you have a big wrap pile, you can use that to do cold central plant recycling. So starting from the mother wrap pile, you can fractionate it for better control, and then that's if we go to the second picture, then you can have a cold central plant that has different bin to receive the different wrap sizes. So usually you have fine, medium, and coarse wrap that you can use to feed your cold central plant. And then all the components come together inside a pug mill. So that's where your wrap, your water, your emulsion, and your other additive as needed are mixed together, and then you can use you know, a kind of surge bin to be able to continuously produce the cold mix and still kind of load truck by truck, and eventually you have your cold mix inside the truck ready to go back to the project and be paved as you would pave regular mixture. So that's kind of the process for the cold central plant recycling. Now for both the CIR and CCPR, the compaction process is really the same. So that was, I'm sorry Jason, that was the previous slide where you basically use heavy rollers to make sure you compact the your cold mix well. That's very important to do that. So let's go to the next slide. So one big question that many people have is, how do we know after we finish the process and it's compacted, how do we know that these cold mixtures are ready for traffic, for one thing, and then that they're ready for the overlay? So there is really a very interesting NCHRP research project that is being completed. Some reports are already available. You probably have already heard about it and know about it, but really this NCHRP tried to answer really that question. And they came up with some interesting tests using two main tests, one that they call the long pin shear device, and this one is really to be used to establish the time to surfacing. And then the other device that's available is the short pin shear device that is used to establish the readiness time for traffic. So out of these two devices, basically you first kind of use a DCP-like hammer to drive these pins inside the surface of the recycle mat, and then it will give you an indication, a number of blows to penetrate the surface. So that's the first metric that you get. Then after the pins are in place in the mat, you will basically use a torque device to shear it and measure the torque that you get. So it's a way to measure the strength of the layer or the stiffness of the mix at that point. So they have established some preliminary thresholds to indicate when these mixtures are ready for traffic and ready for surfacing. Of course, you want to make sure that when you open the cold mix to traffic, you don't have any rutting or any raveling, which is, could be a risk. So this is really what these tests are intended for, to give you more insurance that everything is going to be okay. So I really recommend that maybe to take a look at some of these findings and some of the trends and how the values change over time after a few hours. It's pretty interesting. Great. So another topic that I'd like to mention, it's a very, very kind of hot topic on the hot mix side. So balanced mix design is really using a cracking test and a rutting test, and finding out what is the optimum amount of asphalt that is required to kind of get the best of all worlds. So this concept can actually also be applied to cold recycling, because what we really want to find out is what is the right amount of emulsion. And then also, if I decide to use another additive such as cement or lime, what is the right amount of this additive that would, be a good compromise in terms of cracking or rutting resistance. So there are different cracking tests that can be used as far as rutting resistance. There are also wheel tracking tests that can be used. And again, once you kind of run different options as far as trying different emulsion content, trying different additive levels, so you can map, and that's the picture. I'm sorry, it's a little small at the bottom of the slide, where you put on one axis your rutting resistance and on the other axis the cracking resistance, and try to find out, where is the sweet spot. So are you better off with maybe a low emulsion content, or if I put more emulsion, how much impact does that have on my rutting resistance? And if I decide to use cement, how much more emulsion, or what's the value of increasing my emulsion content in terms of cracking resistance, and so on. So this concept can really also be applied to emulsion-based mixtures to try to optimize them for both rutting and cracking resistance. Next slide, please. So I'd like to mention some interesting work that's being done in our part of the world. So cold recycling is really getting very popular, and it's been done in many places. Of course, the U.S. is more than 20 years that people do cold in place recycling, and recently in our part of the world, we really started in 2006 with cold recycling, and in recent years, people have really kind of tried to push it to the limit and really trying to place the overlay very quickly. So I'd like to share the example of a job that was done in 2019, where you can see in this project, basically the rehabilitation consisted of doing about 3.5 inches of cold recycling, followed with a 1.6-inch SMA overlay. And that is on the interstate or on the expressway with relatively heavy traffic. So what was done on this project was actually to start with the cold recycling in the morning, and then it was kind of finished right before noon. I'm sorry, that the production of the cold mix, because we were doing cold sample plant recycling, started in the morning, and then the paving took place around noon, so between 11 and 11:30 and 1:30. And then on the same shift, on the same day, the overlay was placed on top of the cold recycling. And the roadway was open to traffic in the evening. So basically, the cold mix and overlay were done on the same day. So for this case, we used a bit of cement into the cold mix with enough, again, emulsion based on the balanced mix design to compensate for the brittleness that the cement brings, but benefiting from the extra stiffness that we get from the cement. And you can see the cores that were taken not too long into the life of this rehabilitated pavement, and they turned out pretty nice, where you can really see the SMA overlay on top of the cold recycled layer. So next slide, please. So thank you for making it all the way to the end. So very much appreciated. To summarize what we went over, so we talked about the asphalt emulsion, and again, hopefully what came out of the discussion today was that they are very versatile. They can be used for a variety of applications, from mixing application to spraying applications. And one thing that unfortunately we didn't have enough time to touch on, but it's really the sustainability side of emulsion application, where, you know, the environmental benefit based on energy consumption or temperature of application, you know, is highly favorable. So we talked about the prime coat and tack coat over aggregate bases or dust containing substrates, and formulating so that this kind of emulsion can do as good of a job as possible in terms of penetration going through the dust, and then also trying to minimize the amount of solvent that to be used for, again, pollution control. We talked about the chip seal that can be formulated for adverse conditions, meaning wet environment or cool weather, but also high traffic area, and these applications really rely on a fast breaking emulsion. We talked about cape seals and the possibility to use them on high volume roadways. We talked about sealants and some of the recent products that are available that really combine the friction sand into the mixture and are sprayed on the existing surface of the road and are designed to dry relatively quickly. So next slide, please. We talked about high performance microsurfacing, some of the variables, important variables and formulation steps that can be taken to try to extend the life of microsurfacing or meet specific requirements as far as very early return to traffic and so on. and we introduced one new test to try to assess how quickly a system can be traffic ready. We reported and reminded people on some of the findings from Ncat preservation studies. Again, you probably have heard or seen some of their reports showing some of the benefits of pavement preservations. We spent time today to look at a combination of treatments and some of the value that some of these treatments can bring when combined together. I think one of the key message was that crack sealing is very beneficial prior to doing any treatment to a roadway. We talked about emulsion full depth reclamation as an effective rehabilitation technique and some validation information from main road on that. We also talked about emulsion cold in place recycling and emulsion cold central plant recycling as a very valuable rehabilitation technique. We mentioned the interesting NCHRP 962 report that really tries to provide some guidance on traffic and surfacing readiness. We talked about the possibility to use a balanced mix design concept to further optimize these cold mixes so that they perform as well as possible in terms of rutting resistance as well as cracking resistance. We went over an example of a project on expressway that for which the overlay was placed on the same day as the cold mix was done. And we've done many more projects that way, and so far it's been somewhat very, very favorable. So that's it for the summary. So if we go to the next slide, would like to share a few links that you can consider to get more information or additional information on asphalt emulsions and applications. So if we go to the next slide, Jason, maybe you can mention, say a few words about the next webinar.
Yeah, Stefan, I'm going to pass it over to Anne.
Okay. Thank you, Jason. And thank you, Stefan, for today's presentation. I know we had a little bit of technical difficulty at the beginning, but we really appreciate everyone's time today. Stefan, it was a great presentation. Our next webinar in the series will be held on August 19th at 2 p.m. Eastern Time, and that will focus on identifying roadway candidates and selection for pavement recycling and reclamation treatments. We hope that everyone is able to join us for that. There is a link on the screen that you can go to register, or you can also go to roadresource.org for more information on that. Thank you. Back to you, Jason.
Thanks, Anne.
Okay. So I'd like to leave you with my contact information. So please feel free to reach out if there is anything that you'd like to discuss more, or if you need any more information on some of the details that we shared today. I can also put we're a global company with offices in different countries, so I put our headquarters address in Charleston, in North Charleston, South Carolina, and I just put the address where I'm at our Asia Technical Center in Shanghai. Now, of course, with COVID, that's not easy to do international travel, but you're very welcome to visit us here visit our team here in Shanghai if one day travel becomes easy again.
Thank you, Stefan. Now I'd just like to share with you the presentation material as well as other flyers for upcoming and past webinars that we have. They're in the file share, so feel free to download those. As well as you could please take a minute. We use our evaluations to really address topics for future webinars, so please feel free to use this and fill out appropriately. I greatly appreciate it. Stefan, there are a couple questions in here that we can cover. We got a few minutes. Great presentation, by the way. There was a question about what are the best methods, existing best methods, to evaluate quality of cold-in-place recycling mix? And they preferentially more of the cold center place plant recycling in the field. Do you know of any?
I'm sorry, say again, Jason?
They're asking what are the existing best methods to evaluate quality of cold recycling mix, particularly cold central plant recycling in the field?
Yes,
best
so
practices
in
to evaluate quality.
Mm-hmm. Yeah. So, you know, the first, I think we can refer to the specification, and again, I think there is AASHTO guidelines and some ARA guidelines. In the case of cold central plant recycling, one real benefit of that is before going to the job site, you know, as we saw on some of the pictures, you can collect the mix from the truck, you know, so you can take it to the lab and really do some quality control, quality assurance, and that's actually required to do that. So you can take the samples and compact them in the lab the way it's required to be done in the mix design, and you can check the one of the property that's usually always required to be checked is the indirect tensile strength. So you can make sure that this is above the specification limit. And then you can, as part of the specification, typically you also have a kind of like a TSR, tensile strength ratio, as part of the moisture damage evaluation. So you can also, it probably wouldn't be a routine test for everyday QC, but definitely take a few, check that a few times throughout the project. Also make sure it complies with the specification there. So when doing the ITS, when compacting the sample in the lab, of course you're going to get the density. You kind of run a GMM, calculate air voids, and I think the key is to see how close it is to the mix design, and also if you do control charts, you can monitor, you know, the changes over time. So that's actually what we usually do for the quality control of the mix, going to the paver, going to the road. Now, I think if the question was after you finish the compaction, you know, what to do, what to check, for sure the thickness, you know, you have a target thickness, a target compacted thickness, so you want to make sure you check that. And then also the compaction, how's the density of your mat? So that's very critical. So there are different ways to measure that. So in the US, people use the nuclear density gauge, and that's established during the test strip and at the beginning of the project. Whatever the max density can be obtained is something to be achieved later, you know, as the construction progresses. So nuclear gauges can be used. For places where you cannot use the nuclear density gauge, we use the sand cone test. So that's a little more destructive, so that's not so user-friendly, but it's definitely very important to ensure that these layers are very well compacted, because that will have a very significant impact on performance. And then, as mentioned in the NTHRP report, now some of the new tests are probably very helpful as far as knowing when the mat can be open to traffic or be ready for overlay. The old way for overlay readiness was to take a sample and measure the moisture content, but you know, that's maybe, I mean, that's probably still a okay way, but some of the new tests are probably more indicative of strength, measuring strength, Yeah. So I'm sorry, Jason. I hope I answered the question. That was a very kind of open-ended question a little bit, so sorry if I went on for too long.
No, I think recognizing that report, that has the most up-to-date information from the different types of tests they evaluated, and I think you did great. Just one last question, Stefan, and then we got to kind of close for today, is what balanced mix design thresholds would you suggest for cold-in-place recycling, such as the HWT rutting, which I'm not familiar with, but are you aware of any? Or any thresholds?
So that's a very good question. So we've done a lot of work, and there's no official standard on that yet, because it's kind of fairly new. So the Asia and Europe, they use their wheel tracking test, which is not like the U.S. I think most people in the U.S. like to use the Hamburg wheel tracking test. So these can be used. We've seen some really good results even with the Hamburg wheel tracking test, both in the dry and wet mode. But there's no really official, specified requirement that's been approved by AASHTO. It's more maybe, again, in preliminary balanced mix design, because you can do a lot of things in a lab yourself, running different emulsion content, maybe different additives, and see which one, gives you improvements. So relatively speaking, that can still be very useful, even if we don't have thresholds established right now. Because sometimes it's very difficult. These tests were originally designed for hot mix asphalt or asphalt concrete. So we're kind of using them for cold mix. So, maybe we can't get the exact same requirements, but maybe we can. So still probably more work to be done to really validate what these thresholds should be. I think we have some ideas based on the work that we've done, but I don't know, it wouldn't be official.
Great. Well, Stefan, I really do want to appreciate your time. Thank you very much, and I'll leave it with you for any final comments, and then we'll wrap up for today.
No, thank you, Jason. I think really great. Really appreciate the chance, and I know there are very knowledgeable people on the line today, and they probably have other ideas about emerging technologies that would be really worth talking about that I didn't cover. So I apologize if I did not, and hopefully everybody can find an avenue to emphasize some of the techniques that can be very beneficial to road owners to maintain and rehabilitate pavement. So I realized looking at the attendee list, there were some really knowledgeable people on the call, and if they have any feedback or anything that they'd like to share, personally I would appreciate to maybe follow up with them.
Thank you, Stefan. And that will conclude our webinar for today. And Catherine, I'd like to sign off. Thank you, everybody.
Thank you, everybody. Bye-bye.
That concludes our conference for today. Thank you for your participation and for using AT&T teleconference service. You may now disconnect.